Alright, welcome back. Today we are going to be solving systems of linear equations using substitution. Again, it is a system of equations because there is more than one equation and they're going to be working together to help us figure out what the values of x and y are. I like to think of it kind of like the muscular system in your body. The muscular system is made up of multiple muscles, but they're working together for that common goal to help your body be able to move. Same thing is going to happen with our system of linear equations. X and y are both going to have their own values, but they're going to work together to help us figure out what that one possible solution is of where those lines would intersect if we were to graph them. Using this idea of substitution means that we're going to take the values that we know and we're going to substitute them or replace them in a second equation to make one equation that only has one variable. That way we can solve to figure out what that one variable is going to equal. So let's go ahead and get started. Alright, in our first system of equations here, we have x is equal to 2 and y is equal to 3x plus 5. This is really more of a fact saying that x is the exact same thing as 2. That means that the two are interchangeable and I can substitute a 2 in for the x in the second equation. So when we do that, we're going to rewrite this equation as y is equal to 3, and now instead of an x, we're going to be multiplying by 2 and then adding 5. From here, because we only have one variable, we can start to solve to figure out what y is going to be equal to. So if we take 3 times 2, that's going to be 6, and we're adding 5. I know that 6 plus 5 is equal to 11, so that means that y is going to be equal to 11. So we now know y is equal to 11. We were also given that x is equal to 2. We're not really finished solving the system of equations until we have both an x and a y value, but here, because we were already given a value of x, we can say that we're finished. We just want to make sure that we write our final answer as a coordinate point, because really we're solving for the point where those two lines would intersect if we were to graph them, and that would be at the point 2, 11. So let's try a problem that's a little bit more challenging. Here's our second problem. This one's a little bit more challenging because x is now equal to this entire quantity. X is equal to 5y plus 3. That means that 5y plus 3 and x have the same value. So in my second equation, wherever I see an x, I can substitute this entire quantity in. So again, we're going to rewrite it. We're going to start off the same, so 2y plus 3, but now instead of writing times x, I'm going to write times the entire quantity of 5y plus 3. And I'm going to use the parentheses to make sure that that entire thing is going to be multiplied by 3. It's still going to be equal to 26 because that hasn't changed at all. At this point now, we have only one variable, so we can start to solve. So we're going to use the distributive property to get rid of our parentheses. That means that 2y plus 3 times 5y is going to be 15y's. And then 3 times 3 is going to be 9. So we're going to be adding 9. It's still going to be equal to 26. From here, we can combine our like terms. So 2y's and 15y's is going to be 17y's. And then we still have plus 9 is equal to 26. And then from there, we're just going to solve. So we're going to subtract 9 on both sides. When we do that, we end up with 17y is going to be equal to 17. And then once I get here, I know that 17 times 1 is equal to 17. So that means that y is going to equal 1. From there, I'm really most of the way finished. The only problem is that I don't have an actual value for x yet. I was given the statement that x is equal to 5y plus 3, but I don't know what that value is. So now we're going to take this 1, because y is equal to 1, and we're going to substitute it back into this equation. That means that 5 times 1 would still be 5, plus 3 is going to be 8. So x is going to be equal to 8. Okay? And once again, we want to make sure that we write our final answer like a coordinate point so that we could tell where the two lines would cross if we were to graph them. And since we always write our x first and then our y, it's going to be crossing at the point 8, 1. So our final answer for this one would be the point 8, 1, or x equals 8 and y equals 1. Alright, so in this example here, we see that we do not have a variable that's already been solved for. We don't know what x or what y is equal to. So we might need to rearrange some equations before we can do that. If we look at this top equation here, 2x, the 2 is a coefficient in front of the x, so in order to get x by itself, I'd end up having to divide. But you might notice here this y is all by itself. There is no coefficient, so that makes this one a little bit easier to solve for y. So if we want to get y by itself, we need to move this 2x to the other side, and we would do that by subtracting it. So we can really rewrite this top equation as y is going to be equal to 1 minus 2x. And now we know that since y is equal to 1 minus 2x, we can substitute this entire value into this equation down here for y. When you do this, I'm going to be a little bit careful because I know that this is really a negative 1y. I am going to write it as negative 1 and then times the entire quantity of 1 minus 2x because I want to make sure that that negative 1 gets distributed to that entire quantity again. Then I'm just going to rewrite the rest here, so 3x equals negative 11. From there, we would distribute once again. That would leave us with negative 1 plus 2x, and then we still have plus 3 equals negative 11. Okay, again, we're going to combine our like terms. So we have negative 1 plus 5x is going to be equal to negative 11. And then we're going to add 1 to both sides. That's going to leave us with 5x is equal to negative 10. I can either think about dividing both sides by 5, or I also know that 5 times negative 2 is going to get me to a negative 10. So that means that x has to be equal to negative 2. Once again, we're almost finished. We've solved for one variable, but we have to solve for the other. We can use any of these equations at the top here now that we know that x is equal to negative 2, but this one that we rewrote is actually going to be the least amount of work. If we take a negative 2 and we plug it into this one, we just simplify this side, and that's what y is equal to. So I'm going to go ahead and do that. I'm going to end up doing the multiplication first when I follow the order of operations. So I know that I'm going to have a negative 2 times this negative 2, and that's going to be a positive 4. So I really have 1 plus 4 is going to be equal to 5. So y is equal to 5. And once again, we want to rewrite this final answer as a coordinate point. So it would be rewritten as negative 2, comma, 5. And don't forget to put your parentheses around to show that it is a coordinate point. Hopefully these 3 examples were helpful. When it comes to substitution, it really just takes a lot of practice. You start to find those patterns, realizing how you can substitute them from one equation to another equation, and then just don't forget that you need to distribute to get rid of your parentheses and always combine your like terms. Then you can. So again, hopefully this video was helpful for you. If you have any questions, feel free to comment below.